All right, welcome back, folks. So in the last section, we talked about how to find a confidence interval if the population standard deviation is a known value. In general, that's not always the case. And so in this section, we're going to talk about what to do if the standard deviation or the population standard deviation sigma, if this value is not known. Look at today, we're going to learn how to construct confidence intervals for a population mean when the standard deviation is unknown. So when we found confidence intervals for a situation where the population standard deviation is known, we use a z value to calculate the position in the distribution and therefore to calculate the probability. Okay, but really, really often we don't know what the population standard deviation is. And we can't really use the normal distribution in that case. We have to use a different type of distribution to find the area. This is the only difference between what we did before and what we're going to do now, is that we have to use slightly different distributions. So instead of the z distribution, right, we use a family of what's called t distributions. Okay, and they all change based on the number of degrees of freedom. We're going to talk about degrees of freedom more as we go along, but it is essentially the number of values in the data set that are allowed to vary. And so in this case, n minus 1. And so it's always, when you're doing this type of confidence interval, it's always going to be the number of data points minus 1. Now, as we add more and more to the sample size, we get closer and closer to the population. In that case, the degrees of freedom, they increase, and the t distribution will approach the standard normal distribution. As you get closer and closer to more and more degrees of freedom, you can see here the black line in this picture is the standard normal distribution. Okay, with 1 degree of freedom, the t distribution is down here. Right? Notice that the area on the edges are wider. Okay, and this is essentially the difference, right? We can't be sure that all of our data are going to vary in a particular way if we don't know the standard population standard deviation. And so we use a slightly different distribution, which calculates the areas in a slightly different way. So we just need to do some things a little differently, but most of the calculations are going to be very similar. We're just using slightly different values. For example, we're going to calculate the margin of error using the sample standard deviation now, instead of the population standard deviation, and the sample size. And in addition to that, we're going to use a critical t value. Okay, so there are a few ways to figure out these critical t values. The first thing that you need for sure is the degrees of freedom, right? And so notice that's listed over here in this table. And then they've got 2 columns here. I will tell you in general, you'll focus on this column in the center, but you may need some of the other ones as well, depending on what the question asks what the confidence level is. Okay, that's what you're seeing here. 95% and 5%. It may sometimes be easier as well just to use Excel to calculate the critical t value at this point. And notice that we get the same for 0.05. 0.05, notice the 2t here is telling it that it's 2 tails. And we get the same number essentially. Rather than add the Excel spreadsheets in this time, I've kind of just included them along to save a little bit of time and change in the video. So let's say we want to find the margin of error here. Let me change let's say we want to find the margin of error. There's our critical t value times the sample standard deviation divided by the square root of m. In this case, we have a sample set of heights. We have 17 degrees of freedom because there are 18 people in the sample, n minus 1. And so that will give us a critical t value that I showed you just a moment ago. It's 2.110, or just 2.11. The sample standard deviation, we'll just call it 3.64. Divided by the square root of 18, the square root of m. So be careful here. You use n minus 1 to find the critical t value, but you still use n to find the margin of error. If we calculate this, 2.11 times 3.64 divided by the square root of 18. We get a margin of error of 1.81. And so we can use this margin of error to find a confidence interval. And I think that's coming up in just a second. So let me review one more thing here that I think you will find helpful. When you have just the confidence intervals, okay, but not the point estimate, not the value in the middle, you can calculate that value in the middle and the margin of error with just those two limits. Okay, so here you see you can find the margin of error by taking the upper limit minus the lower limit divided by 2, and that's what you see here. Okay, but you can also find this point estimate by taking the upper limit and the lower limit and adding them and dividing by 2. So 48 plus 66 divided by 2 is 57. So this would be 57 in the middle here. And so this is just a way to show you how you can get to that value in the middle very easily, and you can get to the margin of error very easily if you have the two boundaries of the confidence interval. So let's take a look at some examples. Here we have a potato chip company wants to evaluate the accuracy of its bag filling machine. So bags are labeled as 8 ounces. We want a simple random sample of, we're going to take a simple random sample of 12 bags with a mean weight of 8.12 ounces and a sample standard deviation of 0.1 ounces. We can say that it's reasonable to assume it's approximately normal. Okay, so that's important. We want to construct a 99% confidence interval for the population mean weight of the bags. So let's find the confidence interval, right? To do that, we need the margin of error, which again is the critical t value times the standard deviation divided by the square root of n. To find the critical t value, which is really the newest thing, okay, and the toughest part at this point, okay, we can use Excel to do this because we want a 99% confidence interval. Then we want 1% to be split across the two tails so that you have 0.5% here and 0.5% here. Okay, and so that's why you see the 2t here. We will use a slightly different command later, but for now, this is what you'll use for confidence intervals. And this will give you the critical t value. Notice you need the degrees of freedom, which in this case, n-1, which is 11. Okay, so this is 1 minus 99%. That's the percentage that's left over, and this is the degrees of freedom. And that gives us our critical t value, which you see here, 3.10. We can call it 3.106 times the standard deviation of 0.1 divided by the square root of 12. We plug that into the calculator. You should get, let's check this real quick, 0.0897. And then to find our confidence interval, we want to add and subtract. And so that is 8.12 plus 0.0897, 8.12 minus 0.0897, 8.03, and 8.21 if we round. And so we can write the confidence interval that's going from 8.03 to 8.21. So we can be 99% confident that the mean weight of the bags of potato chips is going to be between 8.03 ounces and 8.21 ounces. So they might actually be able to label their bag as being a little more because it's always a little bit more than, or almost always a little bit more than 8 ounces. Let's look at another example. Company's developed a new type of light bulb, wants to estimate its mean lifetime. We take a simple random sample of 100 bulbs with a sample mean of 750.2 hours. and a sample standard deviation of 30 hours. We want to find a 95% confidence interval for the mean lifetime of the light bulbs. And so we're going to need our critical t-value. Okay. The degrees of freedom in this case, n minus 1, which is 99. And this is what I wanted to show you over here. That's why there's two you see here. First of all, let's just look at this as that Excel command again. We're looking for a 95% confidence interval, so the area left over is 0.05. Okay, and then our degrees of freedom in this case is 99. Now, if you use a table for this, most tables won't have every single degree of freedom, right? So it might jump from 50 to 100 or something like that. And then sometimes it goes 50 and then like 100 and then 200, and then it's just the Z distribution essentially. In this case, I just wanted to show you it's not that much different going from 55 to 99. I just picked 55 because it was close to 50 and that's where tables generally stop. But notice there's really not that much difference in these two critical t values. Okay. The second one's more appropriate, but what you're seeing in the tables when they do this is going to be an approximation. That's why you're told to go to the higher degrees of freedom in the table if it's not there. So if it stops at 50, right, and the next one up on the table is 100, you would go to 100. Okay, or you can just use Excel, because in my opinion, it's just much easier to do it with this one command. Okay, and that'll give us the critical t-value that we need, 1.984. To find the margin of error, it is 1.984, the critical t-value, times the standard deviation divided by the square root of the sample size. The square root of 100 is 10. That's a lot easier to do. 1.984 times 30. That's just 1.984 times 3. 5.95 for the margin of error. So now we can use the margin of error and the sample estimate to find the confidence interval. 750.2 plus 5.95, 756.2, 750.2 minus 5.95, 744.3. And so we can be 95% confident that the mean lifetime of the light bulbs will be between 744.3 hours and 756.2 hours. Let's do one more example. Corporation maintains a large fleet of cars. Based on the sample, we want to find a 90% confidence interval for the mean number of miles driven, assuming that it's normally distributed. And so here's the Excel output. And we've got all the distances listed here. We can find the mean. So our sample mean, 2,364. Our sample standard deviation, 236.8. N's equal to 12. So the degrees of freedom in this case is 12 minus 1, which is 11. And then we can find our 90% critical t-value. If you go to Excel, inv.2t. Okay, so 90% means there is 10% left over. And we have a degrees of freedom of 11. Okay, and that will give you the number that you see here. So our critical t-value, 1.796. And then to find the margin of error, 1.796 times the standard deviation of 236.8 divided by the square root of the sample size, which is 12. When we plug that into the calculator, divided by the square root of 12, 122.77. And now we can find the confidence interval. Let's call it this is about 122.8. 2364 plus 122.8, 2480, 2,486.8 miles. We'll subtract 2241.2 miles. And so we can be 90% confident that the mean travel distance for the cars in this fleet is going to be between 2,241.2 miles and 2,486.8 miles. Next week, we will talk about how to solve similar problems when you have proportions rather than means. Please let me know if you have any questions about any of these examples, and I will talk to you guys next week.